Hello, today we're going to talk about powers, index notation, and the index laws. You remember from previous studies that when we represent a number like this, we mean 2 multiplied by itself 7 number of times. So it's a repetition of the multiplication, 2 times 2 times 2, 7 times. The big number that is multiplied by itself a certain number of times is called the base. In this case, number 2 is the base. The number that is telling us how many times we have to multiply the base by itself is called the power or the index or the exponent. The whole expression is read 2 to the power of 7 or 2 to the 7th. A couple of expressions are more common than others, so they have special names. When we write, for example, 2 to the power of 2, we usually say 2 squared. And when we say 2 to the power of 3, we say 2 cubed. Please remember that when we write minus 2 square, we're saying that the number 2 squared must be preceded by the negative sign. So we have minus multiplied 2 times 2, which is 4. So minus 2 squared is minus 4. But if we write minus 2 squared, meaning the whole expression has to be multiplied by itself. So this means minus 2 times minus 2. And minus 2 times minus 2 is positive 4. So pay attention to the use of negative signs and brackets with powers. In the first case, the power of 2 must have a minus sign. So the result of 2 squared must have a minus in front. In the second case, we have a whole expression, a whole negative expression that is multiplied by itself. So the exponent multiplies by itself not just the number 2 but the whole minus 2, so the number and the negative sign as well. Now let's look at some interesting characteristics of powers. The first one tells us that when we multiply numbers with the same base, the result will be a number with the same base as well, and for exponent it will have the sum of the two exponents. For example, 7 cubed times 7 squared equals 7 to the power of 3 plus 2, or 7 to the power of 5. And in fact, 7 cubed is 7 times 7 times 7. 7 squared is 7 times 7. And their multiplication is 7 times 7 times 7 times 7 times 7, 5 times. So 7 to the power of 5. Likewise, a division between two numbers with the same base and different exponents will give us, as a result, a number with the same base again, and for exponents, the difference of the two exponents. Once again, a numerical example can help us understand better. 7 to the power of 4 divided by 7 squared is equal to 7 to the power of 4 minus 2, so 7 squared. In the third case, we are raising a power to a power, and the result will be a number that has the same base and for exponent the product of the two exponents. For example, if we take 7 cubed and we raise it to the power of 5, the result will be 7 raised to the power of 3 times 5, or 7 to the 15th power. The fourth case is a little different. We are looking at the multiplication of two different numbers. The product of these two numbers is raised to a power. Now the result will be the product of the first number raised to that exponent times the second number raised to the same exponent. For example, the product of 3 times 2 raised to the second power is equal to 3 raised to the second power times 2 raised to the second power. And you can easily try it for yourself. Do the calculation and you will see how this is true and correct. In the next case, we have the quotient of two numbers raised to a power. So the result of the division between a and b is raised to a power of m. And that corresponds to raising a to the power of m and then dividing it by b raised to the power of m. For example, the result of 6 divided by 2 raised to the power of 3 is the same thing as 6 cubed divided by 2 cubed. The next law tells us that any number raised to the power of 0 is equal to 1, with the only exception of number 0 itself. So any non-zero number raised to a power of 0 is equal to 1. The last law tells us that when we have a negative exponent, like in this case a raised to the power of minus n, we should consider the base as the denominator of a fraction. So a to the power of minus n equals 1 over a. For example, 7 to the power of minus 2 is equal to 1 over 7 squared. And the opposite is also true, of course. So 1 over a to the power of minus n is equal to a to the power of n. So for example, 1 over 5 to the minus 3 is equal to 5 cubed. You can find all these index laws at pages 55 of your textbook, and I would recommend that you try a few exercises, as these laws are extremely interesting and useful when you need to simplify complicated algebraic expressions.